what is the difference between these two kinds of things in computer science terms? Okay. What does that mean? What is synchronous and what is the meaning of asynchronous? Yeah. Okay.
And asynchronous, you wait for the other person to then reply, then you reply back.
Okay, that's fair enough. So which is better? Well, basically message passing, let's say there's some information you want to convey, right? I mean, that's one purpose for which we do message passing, right? So which is better?
Because immediately you can find out that you received the message.
Okay. How do you prove that? That's related to what you are saying, but I want a mathematical statement. Right. See, all these things I'm talking about is not what I do research on. I am basically a theoretical computer scientist, so I do research on things which are mathematical. Right. So if I want to ask such a question, then I'll have to pose it mathematically and try to answer it mathematically. I'm just trying to give you some idea of how one does this kind of thing. Right. So supposing you have some information, let's say I, or let's say F, it's a fact. Okay. And this is me and this is you, let's say. Okay. So when I say that, so let's say I know F at this point. Okay. And then I send this message to you. Okay, so you know F at this point. But there's something more. Okay. You also know that I know F. Okay. But I don't know that you know F. And that's why I'm trying to send the message to you. And maybe you know, but at least I don't know it. Right. So whatever, let's suppose what Baba Ramdev has been just arrested at Rajghat or wherever. I know this, okay, but I'm not sure whether you know this or not. So I'm sending this message to you. Okay. So how can I guarantee that I know that you know F? and then, yeah. So once you get this, you send me an acknowledgement. Okay. At this point, I know that you know F. Okay. But at this point, okay, you don't know this. You don't know that I know that you know F. Okay. How will you get to know this? If you send an acknowledgement to this. Okay. So basically, by kind of nesting this I know you know business several times, I can always find some statement which is true for me but not for you, or true for you but not for me. So it depends on which side you are on. I can always find such a statement. Okay. Whereas if I make, let's say, a phone call, okay, then this, let's on the phone call I say whatever, something has happened to Baba Ramdev, then all these statements become true immediately. Okay. So I know this fact F, you know F, I know that you know F, you know that I know F, I know that you know that I know F. Everything becomes true immediately. Okay. So this is a mathematical proof that any number of messages is less powerful than one phone call for the purpose of conveying information. This is a very old theorem. This was proved in the 1980s. So, synchronous message passing, at least for some purposes, let's say. Okay. What is the advantage of asynchronous message passing? Basically, you don't have to wait. Right? You just send your message, and some point that person will get it. Okay. But you don't know when. Right? Maybe you send it, and that person has forgotten his or her mobile and gone on vacation or something. So you never might get it only after they come back from the vacation. Right? So in that sense, this is not that reliable a medium. I mean, okay, you could say it's well, at least that person will get it sometime. But maybe not. Maybe that mobile gets stolen. Okay. And therefore that message never actually gets to that person. Or that person leaves the mobile somewhere, forgets it, something. So, whereas in a phone call, when you give that information, after that the phone may break down, the whole phone system might collapse, doesn't matter, but you still, all this, these I know, you know, everything becomes true. Okay. So, phone calls give you common knowledge between the two parties who are speaking. Okay. Whereas letters don't give you common knowledge. Letters just say that I know something and you know something, but you cannot say that both something is common knowledge between both of us. So in general, as synchronous message passing is a little harder to implement. Okay. I mean, this on machines, but we'll take a look at that in this lecture. On or off? Which one is this? Yeah. Okay. So the key thing which distinguishes asynchronous message passing from synchronous message passing is that there are two communication events, okay, a send and a receive, and they are both different. Okay. In the case of synchronous message passing, there is only one event which happens. Okay. So I say something, here I am saying something to you, that is the event which happened. Okay. So there's, of course, you could break this down further and you can say, okay, I generate some waves in the air here and they get to your ear or something like that. So you could even say that this is asynchronous message passing, but usually we ignore this kind of small delays. Okay, and we say that I say something, you are instantly receiving it. Okay. So, okay. So, but you can send a message without waiting. That's the advantage of asynchronous message passing. And synchronous message passing is like communicating with a phone or a web page. There is no separate sending and receiving. It's a bit like making a method call. Okay. It's one transaction which just happens. Okay. But the disadvantage is that even if you only want to send a message, you want to make a phone call and tell somebody something, you don't actually want to listen to what that person is saying, still you have to wait. You have to wait until that person picks up the phone, okay, and establishes the connection. There is no other. Okay. So programmers like asynchronous message passing. Okay. Basically because of you send a message and you forget about it. But then that message has to be kept somewhere in a buffer. Okay. So somebody has to implement that buffer for you. Okay. So and you just put your email on whatever, Yahoo or Gmail or whatever, right? But then Yahoo or Gmail has to maintain that message for you, right? Okay. So even spammers, they use asynchronous. So you get spam mostly through email. Okay. Even on your mobile phone, you get all these things as messages, right? All these advertisements that you get. Right. So there are relatively few people. I mean, I get, for instance, people from banks call me and say, do you want this credit card or something like that. But that's relatively rare because that person who's calling, if she wants to contact 100 customers, she has to actually call them, wait until that person is free, speak to that person. So it takes time. Okay. Whereas for sending a message, they don't have to do anything. Right? So we'll come to this example which we have seen earlier. The reason I want to do this is because I am taking this out of a textbook. Not the textbook I mentioned in the beginning, but there is another textbook. And there is a serious mistake in this textbook. Okay, and that's why I want to take this particular thing. I mean, I think what is being taught is wrong. So let me try to explain that. So, well, here is the dining philosopher, which we have already seen earlier. So there is this table with the whatever spaghetti or noodles or whatever, and there are these 5 forks, and there are these 5 tables. Okay, and each philosopher spends life alternately thinking and eating, right? And a philosopher needs 2 forks to extract the spaghetti and eat. Okay, so now we want to implement this problem. So each fork is a thread and each philosopher is also a thread. Okay, and we'll implement this using message passing. That's the idea. Okay. So here is, so fork extends thread, so it's a thread. Okay, it has some identity. So it's fork number 1 or fork number 5 or something like that. And there are two methods called pick up and put down, and there's a run method. And what the run method basically says is receive an instruction called pick up. Okay, right. So this is, of course, I mean, this is not Java, but we are going to implement this. We are going to implement this inside Java, right? So you receive a pickup message, and then later you receive a put down message. Okay, so this is what you want to do. And I mean, I have taken this to be just dummy messages. You could do something with those pick up and put down. You can say, for instance, maybe you could get the identity of the person who's picking up the thing, and you could print that out, saying philosopher whatever 5 has picked up fork number 4 or something like that. This is the philosopher. That's also a thread. So there's some identity for that thread, and you set these two variables, which is the fork you pick up first and which is the fork you pick up second. And normally we have first thread is I and second thread is I plus 1. Oh, so this is from 0 to 4. Okay, but what we looked at in the first lecture is that the solution has to be asymmetric. So whereas so if this number happens to be 4, okay, then this philosopher number 4, what he or she does is first pick up the right fork and then pick up the left fork, right? So, and then the life of the philosopher is very simple. Thinks and then picks up the first fork, which is a send, picks up the second fork, eats, puts down the first fork, puts down the second fork. Right? And now we have to implement this send and this receive. Okay. So it's a very straightforward example. Okay. And earlier, and we could have even written this using our mutual exclusion primitives which we had earlier, but now we are trying to implement it using message passing. Okay, here is a main program. Okay, so what does the main program do? First, it creates an array of fork threads, so and starts them off. It creates an array of philosopher threads. Okay, that's all it does. So you have basically a class called dining that has to have a main method that says that this is the program which will start executing as far as Java is concerned, and then it creates all these threads 0 to 4 and starts them off. Okay, so now we have to decide whether the message passing is going to be asynchronous or synchronous. Okay, and how is it to be implemented in Java? And everything else we know about this, how everything else works. Okay. So here is how we implement asynchronous message passing between threads. Okay, so there is a Java class called selectable. Okay, and it has two synchronized methods. Okay, which means that these will happen atomically. Okay, so the execution of this method call will be, there will be a lock controlling that. what you do is, so there is a send method and you can send any object that you like. Then there is a receive method, okay, and there can also be an exception on this receive method. Actually, even on the send there should be. Anyway, so okay, so here is, okay, so this is producer consumer. This is not dining philosophers, but it doesn't matter. So so producer implements runnable, so it's again a thread, okay, and what does it do? Well, it creates an object of this type, a private object. This is the channel between the two communicating parties, okay, and what does the run method say? It tries to send an integer n, okay. Right. So basically what this is doing is it just keeps on sending numbers. It sends 0, then it sends 1, it sends 2, etc. Okay. And this goes on forever until you do Control C or something. At that point you have an exception and it comes out. So that's the, and this is the consumer. Okay. What the consumer does is, so it also implements runnable and it has also the same port number. Right. What does it do? Well, it basically gets whatever is sent, whatever is comes on this channel, on this port, it gets that, and this is a type object, because any object can be sent, so you have to cast it to integer, okay, and then you print this integer. It also goes on. Okay, so this is an infinite loop, and at some point there is an interrupt and you come out of it. Okay, so this is the idea of asynchronous message passing. So basically there is just a class called selectable, okay, and so this port is created with send and receive methods which extend this class. That's all. Actually, I don't know why it could have directly used selectable, why it was necessary to create a local class, but still. Okay. Now we do synchronous message passing. Okay. So synchronous message passing, there is a class called channel which extends selectable. Okay. And there is a synchronized method send which throws an exception. So in this case you see that send actually throws an exception. A synchronized method receive, which throws an exception. Okay. Now you have a sender which has a private channel class. Okay, and what does it do? N is 0, and then in the loop on the channel it sends an integer, increments, plus Control C comes out. Okay, so this is receiver. And you can see what receiver does. In an infinite loop, it receives something, casts it to an integer, prints it out, and then there is a Control C to break this. Okay. So this is from this textbook, which says this is how you implement synchronous message passing and asynchronous message passing in Java. But I claim this is nonsense. This is just a mistake. Okay. Why is it wrong? What is wrong about it? And you can try this; it will work. Right. So the first thing to be suspicious about is that there is basically no difference between asynchronous and synchronous message passing. You call it port or you call it channel, they're all names, right? But there's actually no difference at all that is going on. Okay, and it all seems very easy. So what is wrong? Yeah. So what is wrong is it's that you're doing message passing between threads. Okay. So what do we mean by message passing between threads? For instance, here we are, this is a classroom. Let's say I am a thread and you are a thread and you are a thread and so on, right? And you pass a note, to write one little note and send it to him. Okay. So is that synchronous message passing? Is that asynchronous message passing? It's asynchronous message passing. Okay. Instead, supposing you just talk to each other, is that synchronous message passing? Is that asynchronous message passing? What was the difference between synchronous message passing and asynchronous message passing? The difference was that for instance, that when I send a letter, okay, I don't know that you know that information, right? But when he gives a chit to out there, does he not know whether that person knows that information? He knows, because he sees he sees the chit going there and he sees that person reading the note. Right? So what I'm saying is, in this situation, what you have is only passing. There is no asynchronous at all. Asynchronous message passing happens when you post a letter and now you don't know when this is actually going to be received and what is going to happen at that point. You have no control over that receipt. But here that is not the case. Right? So this is a wrong example of synchronous and asynchronous message passing. Okay. What is the problem in general with threads? That you have all these threads, okay, and you have some class, whatever, selectable or whatever class, okay. How does that work? That selectable class will basically have a buffer. It will maintain a buffer, okay, and when you do a send, it will put this in the buffer, and when you do a receive, it will take this off the buffer, right? But this buffer is a shared object between the selectable class, between these two threads, between all the threads in memory, in fact. Okay. Right. So for instance, if this guy did receive, then this thread would get the message. Okay. There is, okay, well, you can do a little more. For instance, you can say that your messages are tagged and then you only pick up the message which is meant for you and so on. So you can do some amount of things like this. But basically there is a shared object. Okay, and whenever there is a shared object, then we are talking about synchronization. Okay, so the message passing that you are doing is synchronous. Right? So when you have threads sharing memory, okay, then the only possible communication is synchronous. Okay, there is no point in calling this asynchronous. Okay, it also depends on how you define asynchronous and synchronous, something like that. Okay, so by that definition, this is not synchronous, but by the definition which I gave, okay, the definition which I gave is that no, actually not the definition which I gave, the theorem which I stated, okay, which is that the difference between synchrony and asynchrony is that common knowledge is not achieved in asynchronous message passing. Okay, right? That holds. I mean that does not hold here. Okay. So whereas if you sent a message just now on your mobile, okay, saying that Kamal is teaching all this kind of nonsense, okay, then you don't know whether that message has reached your friend who could be in, I don't know, in IIT or Anna University or Calcutta or somewhere, right? Until that person picks up that message. So that would be asynchronous message passing, right? So to summarize, basically message passing has to happen between machines. It cannot happen between threads. And I think I found it shocking that there is a textbook which actually gives this and does dining philosophers. It says, okay, I'm doing now message passing using dining philosophers. Right? Because resource sharing example, and you need a shared resource. So we are talking about things which happen in a shared system, in a shared memory system. Okay? Whereas you have to choose different kinds of examples. Like producer consumer is a better example for message passing systems, where you can assume that the producer and the consumer are on different machines. Yeah. In this. We are saying this person does a send, and then later this person does a receive, right? Yeah. So common knowledge is no, common knowledge is not achieved out here. So what do you have? You have asynchronous message passing. Okay. Between threads. Okay. So the common knowledge is kind of more abstract in the following sense, that what are these threads doing? I mean, how did these threads come to be? Okay. These threads came to be because somebody wrote a program with those threads. Okay. And you have the fact that so the person who wrote that program knows, okay, that this guy will put a message in this buffer and then that guy will pick up a message from that buffer. Okay, so the whole system is kind of completely centralized. Okay, so although you are talking about dining philosophers. Okay, it is an implementation of dining philosophers, which is which is centralized, right? So therefore, what you are doing is, in some sense, you are what it is not important for this guy. I mean, who's this guy? It's not an autonomous entity. Okay. It's some thread which is part of some program which you are writing. Okay. So whereas if you look at other thing which I have been talking about, which is between machines, okay, then you send a message to this person, okay, right? But then that person or that machine, I mean, on the internet somewhere, is an autonomous entity. Okay, that machine may choose to or may not choose to pick up this message. Okay. Whereas here, what happens is that this program has no choice about this matter. Okay. This program has, because you have written the program, so you know it's got to receive the message, and so in some sense, how should I put it? It's like a toy system which you are constructing, to demonstrate that, look, I'm doing message passing. Okay, right? But I'm using actually just one machine to do this. Okay. So it's in that sense that I'm saying that this is not a good message passing example. Okay. A message passing example should happen between machines, or between autonomous entities who have their own independent ways of acting. Okay. So that's one answer to it. Okay. So I've tried to illustrate here how passing in machines is implemented. So the Java class selectable implements message passing only between two threads on the same machine. Okay. And they are implemented using just the ordinary synchronization which we saw earlier. Right? Because you use those synchronized methods, that's what you use. So that's the usual locks which we use. Okay. Whereas what we want to have is to have message passing between two processes on different machines which communicate through a network. So in particular, you should somewhere hit the internet, because all you are doing is within one machine. And things harder. Okay, so for asynchronous Java classes with, for example, use TCP/IP. Okay. So how is this done? Okay. So first you have something called a connection. You have to set up something called a connection, which is between two machines, and at both ends you have to have sockets. Okay. So first you establish that connection between two sockets, and then you have something called a stream, which is a sequence of messages which is sent over a connection. Okay. And so long as the connection is okay, so long as there is no crash in the connectivity between these things, messages will not be lost. They will be delivered in the order in which they are sent. Okay. So here is something how sockets are implemented. Okay. So this is a long piece of code, so let's go through it slowly. So there is a file server which we are trying to implement. Basically, there is one machine which has a file server, and then there are various clients which try to access files out there, right? So using message passing, that's the idea. Okay. So create something called a server socket with some port number, okay, and fine, and then which one is this is main, right? Okay, let me see how. Yeah. Okay. So my God, this is a huge program. Let's see first. Right. So what the file server is trying to do is first to get a file name and then send that file. That's the job of that. That's what the server has to do. You send it a file name. You say I want this file, and it comes. That's all. Okay. So first is waiting for a client connection. So you create this. You have created the socket S. On S you do an accept. Then some client has come. Okay. So then you set up streams to talk to the client. So there is a stream called from, okay, which is a reader. Okay. Then there is an input stream reader. Okay. Then you create a 2, which is a print writer. You get an output stream. Okay. Then finally you get your file name. File name the reader, which, and you get a line from it that contains the file name. Okay. And so now you create a file. Okay. First check whether this file exists inside your. You are a file server, so you have to check whether this file exists. Okay. If it doesn't exist, the message saying cannot open this file. Okay. And you close. And you close everything. And sockets. Otherwise, what do you do? Otherwise, the file exists, so now you have to send the file. Okay. And basically line by line. So this loop, what this loop is doing is from the file line and sending it on this channel 2. So it's going to the client. Okay. And finally you close everything. And there's for catching exceptions. Okay. So this is the, I think the client side is also fairly simple. So what does the client do? Okay, so first it has to have some domain address and then the file name. So first creates a socket for a connection to this domain on this local or maybe on that port of this domain. Okay, then you open the IO streams. So now this one has a from and a to as well, which it opens. But of course now its from and to are different from the other guy's from and to. Okay, and you okay. So you send the file name. Okay, so you first print it to the. So this is buffered IO. So you have to flush the buffer to make sure that actually the message goes. Okay, now you wait. So and so long as you keep getting lines from it, maybe you get them and you print them locally. So that's what this client is doing. Okay. Okay, and yeah, so that can be an exception. Okay, and so basically you compile each program on its host machine. Okay, so on so for instance, for the server you would compile it using on the Java compiler there. For the client you compile it using this kind of thing. Okay. And you can have more clients and basically the server runs forever. Okay, and now you can think of various kinds of errors which might happen. For instance, maybe the client starts running before there is a server, then what will happen? or if two clients try to connect to the server at about the same time, then what's going to happen? Okay, so these are all different things which. Okay, but my point is not to really tell you all this, but to say that although this is kind of long and tedious, but this is the amount of detail which you have to do to actually get to connect to another machine. Okay, it's not some selectable class and you call one method in it and you are done. Okay, it's a much harder job to actually set up a connection and send something. But this is typically the kind of thing which when you say send a message, send an, let's say, an email message on whatever, Yahoo or Gmail. This is what the client, that server is what the Yahoo browser, so that's what the server will be at, let's say, yahoo.co.in or wherever. Okay. And it will be, you will be typing in lines of your email and it will be accepting those things and saving them somewhere. Or when you want to read an email, somebody's email, then you click saying I want this email, and then it sends out lines to your screen. Right? This is exactly what it's doing. Right? Okay, so here is a summary. Okay, so to program the server, you first create a new server socket, wait for the socket with which the client connects, create input and output streams for using the socket, and use the streams after that. Okay, to program the client, you open a socket connection to a port on a host. Okay, you create input and output streams for using socket and then use them. This is the how you do asynchronous message passing. So now we'll do synchronous message passing, and there are different ways of doing this. So one thing which Java provides is called remote method invocation. Okay, for doing actually synchronous message passing, and there are these two packages, java.rmi and java.rmi.server, okay, which have classes which support synchronous message passing. Okay, so there are various conditions which you have to fulfill. Okay, so this time what I have the same this thing. Basically, there is some database, okay, which maintains some information, and you want to synchronously connect to that database and get that information, let's say. Okay. Okay. So you have this class database which extends class called remote, and there's a read which throws remote exception, there's a write which throws remote exception. Okay. Then there is, you have to write a server class. The server class must extend this particular class and implement the interface methods. Okay, that's not all. Each server object has to be registered with a registry service. Okay, so this is a program maintaining a list of registered servers on a host. And before running the server on the host JVM, you must run the registry as a background job on the host. Okay. So this is what you have. So this is a database server which extends this class, and it implements the class database, and what it contains is this data which I am taking to be the database. In general, of course, there will be some more complicated thing here. Okay, and okay, then this is database server. Okay, what the read class does is it just sends that one data bit item which I have kept, and what the write does is sets the data value which it gets. Okay, that's all that the write class. Okay. So what does the main program do? So first it sets up a database server. Okay. Then it has to register itself. So you have to provide some address for it. Okay. And then you have to call some class which actually puts that in the registry. Okay. Then you print out a message saying this thing is now running. Okay. Okay. So this is, so what will happen? So you compile the server with Java C. Okay. Then you have to run an Rmi compiler, RMIC. Okay. So what it does is it creates a skeleton stub for each method on the server side and a proxy stub for each method on the client side. Okay. And now what the JVM will do is whenever you actually try to do these calls, it will run a synchronization protocol, which will ensure that messages are between the proxy and the skeleton, there will be synchronous communication taking place. Okay, the remote client is more complicated. So apart from the registry, we have a also. Okay, so again, this code is showing how all that is done. So you first call some set security manager. You set that up. Okay. Then for this is the database. So you say, okay, I want to now look up this string. So the string S is the thing I want. So, and then you pick up the first argument, which is the first argument was the host name. So, okay. No, the first argument is probably the value. What is the host name? Right. So anyway, so you get this thing. So you do a read so many times. So it's just put in a loop. Okay. And what you are doing is you read the value and you do write and send value plus 1, and you read value and value plus 1. So it's just some trivial program to illustrate how this is done. And there is something to catch exceptions. Okay. So here is what you have to do. You have to first create an interface class which extends java.rmi.remote. Each method throws remote exception. The server should extend this unicast remote object class and implement its methods. It should be compiled with Java C and then with RMIC. Okay. So, okay. On the server side, you basically start running the registry as a background job, and then you can run Java database server, and the database server starts running. On the client side, you have to first set up a security manager. Okay. Then you run the client using Java client with this n. So this is the number of this is that n which was being used inside. So what the client does, it looks up the server, it makes a connection, and now what you can do is that the server's methods can be called by the client. Okay. Now there is a synchronous connection set up between using this proxy between the client and the server. So whatever methods are there in the server class now become available to the client, and this guy can now make any method calls and do anything. Right. So this is the. So again, as I said, I'm sure there are other ways of programming this. Although this is just something which I picked up from this book. The point which I want to make is that this is again it's much more complicated. Just setting up a connection between two machines, right? And the other thing which I wanted to show you is that if I want to make up a synchronous connection, and if I want to send you just a message, an asynchronous message, there is a difference. There is a significant difference in the way it is done, right? Because here for setting up between a synchronous connection, you require to set up something between both parties. Okay, so for that you have this whole business of registry, and you have to set up all these kind of things. You have to set up a proxy locally, okay, and you have to communicate through that. So all this is to enable. So ultimately, Java will run some kind of protocol by which the synchronous message passing will run. So that is so that will be, how is that implemented? That will be done using the way you do producer consumer or something. Okay, so there will be a distributed version of that. Okay, but this whole thing is implemented by Java. Okay. Then you are actually able to do this kind of communication. So it's a very long and complicated business, but I don't think it's this is just some side issue, which is that supposing you want to implement synchronous message passing using asynchronous message passing. Okay, so I said that synchronous message passing is powerful in the sense that you immediately get this common knowledge, right? But you can actually implement that. Okay, so what you want is a kind of guaranteed communication between two parties. Okay, so source ready, destination ready, and transmit channel. Okay, so this is the real channel on which the message is going, and those two control channels. Okay, and you can actually implement this in the following way. So you do synchronous send. So first you collect the message. Then on the source ready channel you say I am ready to send the message. Then from the destination you say you get an await from that person saying I am ready to receive the message, send the message, put it on okay, and flush the buffer. So at this point you know that the message has reached that person. Okay, so contrary to, although you are using asynchronous message passing, you actually know that that person knows at this point. Similarly, a receive. So you have a buffer, and you wait for a source ready message. Then you say that I am ready to get the message, and then you pick up the message from the buffer. Right? So when you pick up this message from the buffer, you know that the other person knows that I have got the message. Okay. So by using extra channels, okay, you can actually implement synchronous message passing using asynchronous message passing. Okay, using just this is a very and of course, how will you implement? So this is implementing. How will you implement asynchronous message passing using synchronous message passing? Right? So basically you are using so you use control channels to tell you that message has reached. So this acknowledgement business you are taking care of yourself using this. Okay. Now suppose you want to have a, but the only method available with you is synchronous message passing. how will you do this?
If it was third person and the third person communicates with it.
Correct. So this is actually, so what idea was wrong. This is actually what Yahoo does. Okay, like you log into Yahoo. Okay, so that means server. Okay, and you type in your message. Say send. So that's a synchronous connection setup. So that message. So this is your machine. Okay. What? The recipient comes, okay, and sets up a connection with Yahoo, and then this message is transferred there. Okay. So what Yahoo is doing is actually implementing asynchronous message passing using synchronous message passing. Okay. I mean, so any mailing program, this is what they do. So I've already said that here. Okay. Slide. So first, if you want the messages to be first in, first out, then you have to maintain queues. So your buffer should be queues. So again, this is what Yahoo does. It does them in the order in which the messages come. Okay. And supposing there is nobody called Yahoo actually. Okay. So you and the party you want to communicate to, and you have to implement asynchronous. Then one of you has to maintain the buffers. Right. So the question here is which side should the buffers be on? Should they be on the sender's side or should they be on the receiver's side?
On the receiver side. So you put a message into his buffer, then whenever he wants to take it, he'll take it, but you don't know that he's taken it or not from the buffer. So that way it becomes an asynchronous.
Okay, so supposing you are sitting here and the receiver is sitting in Delhi. Okay, so now how will you do this?
Like his PC always stays on, but no one is really looking at his messages.
But you don't know that, right? Okay. So basically, if you want to implement this feature of asynchronous message passing, the thing which programmers like, which is that you just say I have sent it. Keep the buffers on the sender's side. Okay. So because your message just goes into the buffer. So as far as you are concerned, it's out of your mind, right? Then the receiver at some point has to bother to try and connect and pick up the message, right? Whereas, as you say, if it's more important for you that the message actually reach that person, okay, then you assume that that person's PC is on or something like that, and at this point you make the connection and you say, okay, it's at least reached the receiver's machine. Okay, now when the receiver will actually read it, that remains to be seen. Okay. So communication between different processes. So this communication between so just to summarize what I said, communication between different threads is not very interesting, but communication between different machines is interesting and it requires some programming. But I would say Java provides a lot of facilities, or I don't know, whichever your favorite programming language is, that will also provide some facilities to do this. So something which I tried to find out on the net, but I was not able to is, I mean, for example, you want to set up a social networking site. Okay, how would you do it? I mean, in some programming language like Java, right? So you would. So what would you need to set up this thing? Right. So let's just think through what is required for that. But now you have to teach me because I don't really use Facebook or anything. So, right. So you'll have to tell me what exactly I need to do, right? So, okay. So basically, we want to set up some social networking site. So what kind of things what kind of primitives will I require for this? So I assume that I have several. At least. Okay, I don't know whether there are more servers, but okay, which could be Facebook or could be anything. So what kind of mechanisms will I need to actually implement this in Java? No, no, these are not threads. There are different machines.
So when client 1 and client 2 connect to the server at the same time.
Yeah. So right. So basically, the server will have lots of threads. Okay, maybe one thread will be talking to one machine at a time. Okay. Then.
Going by what Facebook has, this one you need an synchronous and an asynchronous system. Because we have a direct chat also. So there it's a synchronous system, pretty much synchronous. And then you have the commenting and updating this, which is basically again an asynchronous process. With that one.
No, so let's do this slowly. So first thing is, supposing you log into Facebook. I mean, I don't have an account. Supposing I create an account, right? So then what happens? So somewhere this has to record that information, right? So this has some database of people. Okay. Now what happens? So now I would like to say that some people are my friends and so on. How do I do that? And how is that managed here? Okay. No, but the question is here or is it there? Okay. Where is this information? It's on the server. Okay. So let's say on the server, what I have is I'll have some huge graph, right? And so there are various clients. Okay, and maybe there are, I don't know, there are some. So these are my friends, let's say. Okay, and these are people who think I am a friend. Okay, or like that, right? So there's some huge graph which is there inside the server. Okay. Now, I want to post something typically, right? So how would I do that? What would happen in that case?
Whenever the server is processing the request from the client, it will query the database for the
it will query the database for all the friends from the relational database. So it will obtain all those efforts which will be loaded into the client's webpage.
Okay.
Similarly, every part of the webpage, let's say recent updates is one part, then it will query the relational database with respect to time attributes. Then they will be shown on the client's webpage.
Okay. But okay, so kind of thing which you have is very big server. Okay. There is this graph, but then these. So this is, let's say, my account, and then there are other accounts. Okay, and there is kind of lot of information here, right? Fine. Okay. So I don't know. So supposing there's this whatever this Baba Ramdev thing, which I'm using as an example. So this is something I want to post. Okay, and I want all my friends to be immediately aware of this. Right. So what should I do about? I mean, how will Facebook implement it? Okay. Okay. So thing works. So basically, then the server opens up a thread. Okay. I mean, you have one thread here. Okay, and so this through proxies one connection is set up here. Okay. Right. So then you put this message out here. Okay. So this message comes to this thread. Now what happens?
Now it will actually publish it to all other
Signal all the friends.
all the other friends.
Yeah.
Okay. So basically then, okay. So inside this there is also one huge messages. I don't know. I'm guessing. I have no idea how Facebook works. Okay. So this is what it does, and you say, okay, this person in their list of things to be read, there is a pointer to this message. In this person's list, there is a pointer to this message. I don't know. This is one way of doing it, right? But then, okay, and maybe that person could, but then there could be multiple pointers, right? Because there could be many things which are posted here which need to be read. Many phrases. So maybe it's not this, but maybe there's a list out here, and that list goes through this in some in the messages in some order, right? So I don't know. So these are the messages which are of interest to this person. Okay. What else? So then when this person sets up a connection, then you basically connect to this and then give access to all these things, right? Or display them. Anything else which is needed? What else? What other activity is there which will require some kind of communication between, let's say, some different kind of communication between you and Facebook? Or see, so there's one thing which I want to point out here is that this thing is very huge. Okay, because it has to. I mean, I don't even know how many users Facebook has, right? But it's certainly, I mean, well in the millions, right? So you have that many people's information which is kept here, right? Whereas the amount of information which you need is very small. Okay. Which needs to be kept on your machine is a very small amount of information. Okay. So in that sense, it's a relatively cheap thing for you. for your machine. Okay. Somebody is maintaining a huge amount of information, keeping all of this order. Okay. So that's one idea which I want to get across. Let me talk about a different thing. Okay, just now supposing you want to search for something on Google. Okay, you just do a web search for something. How is that implemented? I mean, this is not really part of this course.